Right, now, when you are calculating a gradient, I have already said this in the practical bit, use the biggest triangle you can. Right to the edges of the graph paper. Don't stop part way in. Why would you do that? Go right to the edges of the graph paper. And because it makes your gradient more accurate. And there's a tolerance allowed on these things. But if you only use a itty bitty little mean, miserable triangle, you're much more I mean, your uncertainties become a much bigger percentage. You're much less likely to be intolerant. So use your biggest triangle you can. Okay. And it's obviously delta y over delta x. Make sure that you've right. So when you're calculating a gradient, right? Here is my graph. I'm calculating the gradient, and my graph paper kind of ends there. So I'm going right the way to the edge, right? I'm going to go, ooh, and I'm going to actually write on my graph paper, I'm going to go, right, this is my delta y, and this is my delta x. Okay, and then I'm going to put the gradient is equal to, and it's delta y over delta x, or if this happens to be, I don't know, this happens to be like that previous one, let's make it temperature with time, right? It's delta t over delta t, right? And then what you should do is you should do T1 minus T2 over T1 minus T2. And then you should put the numbers in. Okay, so I don't know, this one is 121 degrees minus 15 over, and this time is 300 seconds minus nothing, because this is nothing. Right? But can you see how if you write it like that, it's really clear how big your triangle is. It's really clear what values you've used. And then plug those numbers into your calculator in that form, and you won't make mistakes.